the probability of getting a prime number is nothing but an event b. N of b by n of s is 3 by 6 is equal to 1 by. That's it. Now just add the number of red and green marbles. So therefore the number of red and green red marbles are 8 and the green marbles are 6. If you add this is total is equal to 14 marbles. Probability of getting the sum as 9 is P of A is equal to N of A divided by N of S. What is N of A? 4 divided by 36. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So in my previous class we have discussed regarding introduction to probability, important terms and definitions in probability and few examples based on the definition. Now in this session I am going to discuss regarding problems based on the probability. So whatever the definition we have discussed in the previous session, based on that I am going to discuss the problems on probabilities. Now let us move on to the first problem. Here, find the probability of getting a head in a throw of a coin. Now what is the sample space here? S is the sample space. Suppose if a coin is tossed, what is the possibility we are going to get? One head and tail. If a coin is tossed, the possibility is nothing but head or a tail. So what is the sample space here? N, the number of elements in the sample space is 2. N is equal to 2. Now what is the question? Find the probability of getting a head in a throw of a coin, right? Now let us consider A. A is an event. Getting an head, A is equal to an event. It's an event of getting an head. So the probability of getting a head, let us define the event as getting a head. So how many heads are here? A is equal to only one head, that is nothing but 1. So here N of A is equal to 1. Now what is the probability of getting a head? So therefore probability of getting a head, P of A is equal to N of A divided by N of S. So N of A is nothing but the number of possibility of getting a head is N of A is 1 and the number of elements in the sample space is 2. So hence the probability of getting an event A, that is nothing but head is 1 by 2. That's it. So listen, when a coin is tossed, what is the sample space? There are two events, head and tail. So therefore N of S is equal to 2. The number of events in the sample space is 2. Let us define the event. What is the event here? Getting an head. So A is an event of getting an head. A is equal to 1 head is there. So therefore N of A is equal to 1. Hence the probability of getting an head is N of A divided by N of S. That's equal to 1 by 2 is the required probability. One more question, very simple. Now let us move on to the next problem. An unbiased dice is rolled. Then what is the probability of getting a multiple of 3 and getting a prime number? So first find the probability of getting the multiple of 3. Then the second condition is getting a prime number. Now before that, write down the sample space. So an unbiased die is rolled. What is the sample space? N of S is equal to, so a die contain 1, 2, 3, 4, 5 and 6 faces. So here the number of events in the sample space is 6. N of S is equal to 6. Now let us define the first one. Let us define an event. A is an event. Define an event A of getting multiple of 3. Multiple of 3. So multiple of 3 is nothing but what is A here? So the multiples of 3 are 3 and 6. 3 and 6 are the multiple of this. So therefore number of elements in A is equal to 2. N of A is equal to 2. Now therefore the probability of A is equal to, probability of A means getting a multiple of 3 is P of A is equal to N of A divided by N of S. What is N of A? N of A is equal to 2. N of S is equal to 6. That's equal to 1 by 3. So probability of getting multiple of A is 1 by 3. That's it. This is how we are going to solve. Okay. See here. So since the sample space contains 1, 2, 3, 4, 5, 6, n of s is equal to 6 here. Now let us define the event A as getting a multiple of 3. Capital A is nothing but an event getting multiple of 3. Therefore, n of A is equal to 3 comma 6, n of A is equal to 2. The probability of getting a multiple of 3 is n of P of A is equal to n of A by n of S, that is 2 by 6 is equal to 1 by 3. That's it. Okay. Now move on to the second part. What is the second part? Getting a prime number. Let us define the event. Let B is an event. B is an event of getting a prime number. So what are the prime numbers here? 2, 3 and 5 are the prime numbers. Prime numbers. So n of B is equal to, there are 3. So therefore, what is the probability of getting a prime number? P of B is equal to n of B divided by n of S, that is nothing but 3 divided by 6 is equal to 1 by 2. So probability of getting a prime number in this case is 1 by 2. That's it. So this is how we are going to solve. Just n of S is 6. Prime numbers 2, 3 and 5 are the prime numbers. So therefore, the probability of getting a prime number is nothing but an event B. N of B by N of S is 3 by 6 is equal to 1 by 2. That's it. Hope you followed. Now, move on to the next problem. A card is drawn from a well-shuffled pack of a deck. That is a pack of 52 cards. Find the probability that a card drawn is red, card drawn is queen, card drawn is black and king, card drawn is red and number card, and card drawn is either king or a queen. So these are the given conditions. Now let us find out one by one. First, a card is drawn which is found to be red. Okay, a card drawn is red. What is given? N of S is equal to 52. Number of cards in the deck, that is the sample space contains 52. Now first condition, yes, number of red cards, n of red cards is equal to 26. So therefore, first one, the probability of getting a red card, probability of getting a red card is, probability of getting a red card is equal to, yes, 26 divided by 52, that's equal to 1 by 2. This is the first condition. So since the sample space contains 52 cards, therefore n of S is equal to 2. And first condition, a card is drawn which is found to be red. So number of red cards in this is 26 cards. So therefore the probability of getting a red card is 26 divided by 52, that's equal to 1 by 2. Now the second condition, card drawn is a queen. A card drawn is a queen. Okay. Now the second one, card drawn is queen. So how many queens are there? So number of queen cards is equal to 4, right? So therefore the probability of getting a queen, probability of the card drawn is queen, probability of getting a card which is queen is 4 divided by 56, that's nothing but 1 over 13. So probability of getting a queen card is 1 by 13. Since there are 4 queen, 4 divided by 52, that's equal to 1 by 3. Now the third one, card drawn is black and king. So the card drawn is black and king. The black and king is nothing but there are 2 cards. Now the card drawn is black and king is third one. So the card which is black as well as king is nothing but there are 2 cards. So therefore probability of black and king is nothing but 2 divided by 52, that's nothing but 1 by 26, that is nothing but 1 by 26. Okay, see here, very simple concept. Third one, the card drawn is a black and king. So card which is drawn is black and found to be king is 2. So black king card contains 2. So therefore the probability of a black which is a king is 2 by 52, that's equal to 1 by 26. Now move on to the fourth condition. What is that? Card drawn is red and the number card. The card drawn is red and it is a number card. Okay. So here third condition, card drawn is red and a number card. So the red number card, the card drawn is red and the number. So therefore there are 18 cards. So here the probability of getting fourth condition, Yes, that is a red and number card. Red and numbered card is equal to 18. So therefore, there are 18 red and numbered cards. So therefore, the probability of getting a red and numbered card is equal to 18 divided by 52. That is nothing but you can divide by 2. 2 9s are again 226 are. 9 by 26 is the required probability of getting a red card which is numbered. Now move on to the next one. A card drawn is either a king or queen. Card drawn is either king or queen. Now what is the condition? A card drawn is either king or queen. That is E. Card drawn is either king or queen. So the card drawn is either king. So here that's nothing but let us call it as M. M of n is equal to 8 cards. So the card drawn which are either king or queen are 8. Therefore, probability of M is equal to 8 divided by 52. What is this equal to? 8 divided by 52. That's nothing but if you divide by 4, 4 2s are again 4 1s are 4 3s are. So that is 2 by 13 is the required probability. Right? Hope you followed. See, very simple problem. The card drawn is either king or queen. So the number of cards are 8. Therefore, probability of getting either king or queen is, the card which drawn is either king or queen is 8 divided by 52. That's equal to 2 by 13. So these are the problems based on the given condition. Now move on to the next problem. Very simple problem. A bag contains 6 white. A bag contains 6 white and 6 white beads and 4 red beads. So 4 red. So totally 10. So a bag contains 6 white beads and 4 red beads. A bead is drawn from random. What is the probability that the bead drawn is found to be a white? Very simple. So the number of white as well as the red beads are 10. So only white beads are 6 and the red beads are 4. What is the probability that the bead drawn is found to be white? So the probability of getting a white bead is nothing but, so yes, probably how many whites are there? 6 divided by 10, that's equal to 3 divided by 5. That's it. Very simple. So how many beads are there? 10. Out of which how many are red are there? How many of them are white? 6 divided by 10 will give the probability, that is nothing but 3 divided by 5. Very simple problem. Here a bag contains 6 white beads and 4 red beads. What is the probability of getting a white bead? So since there are 6 white beads and the total number of beads are 10, 6 divided by 10, that's equal to 3 by 5. So the probability of getting a bead which is drawn to be white is found to be 3 by 5. That's it. Right. Now move on to the next problem. A bag contains 8 red marbles, 6 green marbles and 10 pink marbles. One marble is drawn at random from box. What is the probability that the marble drawn is either red or green? Okay, so first just write down how many marbles are there. A bag contains 8 red marbles and 6 green marbles and 10 pink marbles. One marble is drawn at random from the box. What is the probability that the marble drawn is either red or green? So totally how many marbles are there? Total. So there are 10 plus 6, 16. 16 plus 8. That's equal to 24. 24 marbles are there. Right. So a bag contains 8 red marbles, 6 green marbles and 10 pink marbles. Then totally 24 marbles are in the bag. What is the probability of getting the marble which is found to be either red or green? Right. Now just add the number of red and green marbles. So therefore the number of red and green red marbles are 8 and the green marbles are 6. If you add this is total is equal to 14 marbles. So The total red marbles and green marbles are 14. Let us call it as M. Now, what is the problem? What is the probability that the marble drawn is either red or green? So therefore the required probability is equal to n of m divided by n of, call it as the sample space. N of m is 14 divided by 24. Divide this. If you divide by 2, 2 7s are, 2 12s are. So the required probability is equal to 7 by 12 is the required probability. So the required probability is 7 divided by 12. That's it. Okay. See here, very simple. So a bag contains 14 marbles, that is 8 red, 6 green and 10 pink, out of which a marble is drawn which is either red or green. So that is 8 and 6, add this 14. So therefore the probability of getting either red or green is n of m divided by n of s, that is 14 divided by 24, that's equal to 7 by 12. Now move on to the next problem. This is also an important problem. Two fair coins are tossed simultaneously. Find the probability of getting two heads, at least one head, exactly one head. So how many coins are tossing? We are going to toss two coins. So just first write down the sample space. So the sample space contains, if two coins are tossed, what is the sample space? The first is nothing but head and head, head and tile, tile and head, tile and tile. So number of elements in the sample space, number of events. The number of events in the sample space is n of s is equal to 4. So here, if a fair coin, that means if two fair coins are tossed, then the sample space contains head, 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 tile, tile, head and tile, tile. So n of s is equal to 4. Now move on to the first condition, getting two heads. How many possible? What is the, suppose let us define the event A as getting two heads. Let us write A, first one. A is an event of getting two heads. Getting two heads. So how many? So here that is nothing but A contains head and head. That is nothing but only one possibility. One event is there. So n of A is equal to 1. So therefore probability of getting two heads is P of A is equal to n of A divided by n of s. N of A divided by n of s, that is nothing but 1 divided by 4. So probability of getting two heads is 1 by 4. This is the first answer. Okay, right. Now move on to the second condition, at least one head. At least one head means here is one head, here is one head, here is one head minimum. So at least one head. Let us define the event B as at least one head. At least one head. So therefore the sample space contains at least one head means head and head, head and tile, tile and head. So here n of B is equal to 3. Therefore the probability of getting at least one head is P of B is equal to n of B divided by n of S, that is nothing but 3 by 4. So therefore the probability of getting at least one head is 3 by 4. That's it, 3 by 4. 3 by 4. Followed. Now move on to the next, exactly one head. Exactly one head. Now exactly one head means here it is one head, here it is one head, here no head, there are two heads. So therefore we are going to consider, let us define C as exactly one head. So that is nothing but H and T, T and H. How many are there here? So n of C is equal to 2. N of C is equal to. So therefore probability of getting at least one head is equal to n of C divided by n of S, that is nothing but 2 by 4 is equal to 1 by 2. So the exactly one head is nothing but 1 by 2. Probability of getting exactly one head is 1 by 2, because so here exactly one head is H and T and T and H. So the number of events are 2. So therefore n of C is divided by n of S is 2 by 4 is equal to 1 by 2 is nothing but the probability of getting C, that is nothing but exactly 1 head. That's it. This is how we are going to solve this. An important problem. You may expect this type of question for 3 or 4 marks, right? Now move on to the next problem. 2 dice are rolled simultaneously. Find the probability of getting a total of 9, getting a doublet, getting a total of 9 or 11, getting at least 1 5, right? These are the given condition. 2 dice are rolled simultaneously. If 2 dice are rolled simultaneously, what are the events we are going to get is 6 into 6, 36 events we are going to get, right? Now, if 2 dice are rolled simultaneously, then what is the sample space we are going to get? Sample space 1, 1, 1, 2, 1, 3. Then similarly 2, 1, 2, 2. So like that, the last here it is 1, 6, 2, 6, and the last possibilities 1, 2, 3, 4, etc. 6, 1, 6, 2, and the last one is 6, 6. Totally n of s is equal to 36 events. So the sample space contains 36. Here, if 2 dice are rolled simultaneously, then the possible events are 1, 1, 1, 2, 1, 3, 1, 6, again 2, 1, 2, 2, 2, 6, 3, 1, 3, 2, 3, 6, 4, 1, 4, 2, 4, 6, 5, 1, 5, 2, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So totally 36 events are there. Now let us find out one by one. Getting a total of 9. Total of 9. So in the first row we won't get the total of 9. In the second row also 2 plus 6 is 8. And in the third row from third, fourth, fifth we will get the sum as 9. Okay. Now let us define the event A. A as the total of getting 9. So total of getting 9 means first element is 3, 6. 3 plus 6 is 9. Then next one 3, 6. Then 6, 3. Then 5, 4 and 4, 5. Any possibilities other than this? No. So 3, 6, 6, 3. Again 5, 4 and 4, 9. If you add, you will get 9. So what are the number of events here? N of A is equal to 4. So therefore, probability of getting the sum as 9 is P of A is equal to N of A divided by N of S. What is N of A? 4 divided by 36. What is this equal to? Divide it. 4 9s are 1 by 9, 36. So therefore, the probability of getting a total of 9 is equal to 1 by 9. Now move on to the second one. This is first A, B. So getting a doublet. What are the doublets here? Let us define B is equal to getting a doublet. So the doublets are nothing but 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6 are the doublets. So usually you will get 6. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. How many are there? 6. So N of B is equal to 6. So therefore the probability of getting a doublet P of B is equal to N of B divided by N of S, that's equal to 6 divided by 36, that is nothing but 1 by 6. That's it. The second one is 1 by 6. Now move on to the third condition. Getting a total of 9 or 11. Right. Now already we know the total of getting 9 is nothing but that is 3, 6, 6, 3, 5, 4, 4, 9. And addition to this, total of getting 11. 11 means 5 and 6 and 5, 6 and 5, 5 and 6. That's all. So the third one, let us call it as C. C is equal to total of getting 9 or 11 is equal to this 3, 6, 3, 6, 6, 3, again 5, 4 and 4, 5, again 2 more. So 11 means 5 and 6. 5 plus 6 is 11. Again 6, 5. So how many are there? 1, 2, 3, 4, 5, 6 events are there. So therefore the probability of getting 9 or 11 is equal to 6 divided by 36, that is nothing but 1 by 6. That's it. 6 divided by 36 is 1 by 6. So here this is 1 by 6 again. Now move on to the last condition, getting at least 1 5. Let us define this as D. D is nothing but at least getting 1 5 means, so there should be 1 5 in the event. 1 comma 5, 2 comma 5, then 3 comma 5, 4 comma 5, then 5 comma 5, 6 comma 5. 1 2 3 4 5 6 events. Again reverse it. If you reverse, what you will get? 5 comma 1, 5 comma 2, 5 comma 3, 5 comma 4. Already we have taken 5 comma 5. So 5 comma 6. Count. How many events are there? 1 2 3 4 5 6 7 8 9 10 11. So n of D is equal to 11. So there are 11 events. So therefore the probability of getting at least 1 5, at least getting 1 5 is equal to, that is nothing but 11 divided by 36. So this is 11 divided by 36. That's it. The probability of getting at least 1 5 is, there are 11 units, hence the probability of getting at least 1 5 is 11 divided by 36. That's it. So this is also a very important simple type problem. Hope you followed. So these are very important. You may expect this for 3 or 5 marks, right? So the probability of getting doublets is 6 events, 6 by 36, that's equal to 1 by 6. And the third one, getting a total of 9 or 11 is, so lines as same 3 6 6 3 5 4 and 4 5 as 9, and the remaining 5 6 and 6 5, 5 plus 6 is 11, 6 plus 5 is 7. So totally 6 events, 6 by 36 is 1 by 36. The last one, probability of getting at least 1 5 means 1 comma 5, 1 comma 5, 2 comma 5, 3 5, 4 5, 5 5, 6 5, again reverse 5 1, 5 2, 5 3, 5 4, 5 6. So therefore 11 units. Therefore probability of getting at least 1 5 is 11 by 36. That's it. This is how we are going to solve this problem. Hope you followed. So these are very simple problems. Now that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.